Dear students, let's continue our practice on Mathematical Analysis 1, and today we'll begin new section which is called Ordinary Differential Equations. So the first topic is first order differential equations, Cauchy problem, and equation with separable variables. Let me first explain general definition of ordinary differential equations, which abbreviated ODE. ODE. It means ordinary differential equations. So, and it's indicated by the following equation. So f, in general it is, I will write, with n variables, x, with n plus 2 variables, of course, x, y, y derivative, and then second derivative, etc. till n's derivative equals to 0. This is we call ordinary differential equations, order n. So f here, it's a real map depending on n plus 2 variables. Here we have n plus 2 variables. The differential equation has order n. However, we use here as derivative. The highest order of differentiation is n. And a solution of this ODE is a function y differentiable n times, such that so f x y x y prime x, etc. Yeah, y as derivative of x equals to 0 for all x from any set of A. Here y, this is function of A to R, real line. Okay, now this is general definition. And now let's give a definition to first order differential equations, which we started today. So it is the first order differential equation. It will be it's denoted by y derivative equals to indicated f x y. So this equation we call first order differential equation. Okay, now today we'll consider from first order differential equation, Cauchy problem, and equation with separable variables. So this is first order differential equations, and today we'll consider only Cauchy problem and equation with separable variables. And linear first order differential equations and homogeneous we will consider in the next practice. Okay, let's begin with the Cauchy problem. It's called also initial value problem. Initial value problem. So Cauchy problem or initial value problem. Okay, let me give a definition to Cauchy problem. So let that we have differential function y, and the next we'll consider the next system. So y derivative, it's fxy, and on some set a, for example, and yx0 is equals to y0. So it's given points we have, and x0 from the set of A, y0 from the set of R, set of all real numbers. So this system we call Cauchy problem or initial value problem. It's satisfied. You can see here we have the given values. When x0, it will be y0 it gives. And here we have first order differential equation. For example, so solve the initial value problem. Y derivative. So you know y derivative we can write also in the form, differential form, dy over dx, yeah? So it means also y derivative. And it's equals to 10 minus x, and we have the values. So initial values 0, it is minus 1. So we have to find it. And firstly, we need to solve differential equation. Look here, it will be dy, it's equal to, let me write in generally here. In generally, it will be dy over dx, it's fxy, yeah? So now, when we multiply the dx to the right side of our equation, it will be fxy dx, yeah? And so what does it mean? If we integrate two sides, it will be the integral dy, integral of f of x dx. Hence, we'll get here y is equal to f, of course, the primitive of this function, f of x, and y plus c, yes? And now, why we need this and initial value? So, using this values, we can find, plugging to this equation, and find what we will find. We will find constant c, and we'll solve it for c, and then we have solution of our differential equation. So in this example, the given one, we have dy, it's equal to 10 minus x dx, yes? Or y, if we integrate both sides of our equation, we have y is integral of 10 minus x dx, or it will be 10x minus x squared over 2 plus constant c. So now, this is step 1. Step 1. Now we have step 2, finding this constant c, putting these values. So step 2, what we'll get here. So let's put this initial value. So y0 is minus 1. It means instead of x, we need to put 0 and getting minus 1. So minus 1 is equals to 10 times 0 minus 0 over 2 plus c. Yeah. So now it will be minus 1. So it's just C is, hence we'll get C, constant C is equals to -1. So what we get? We get the constant, yeah, this C. And the solution of our equation now in the form. So here we need to put now, instead of C, its value. So y equals to 10x minus x squared over 2 minus 1. This is solution of our differential equation. I think it's clear for you. It's not so hard to find. Just we should know integration, and it's enough to solve Cauchy problem. And now let's consider the next example, example number 2. Okay, so what we have here we have y derivative. So initial value problem again, 9x squared minus 4x and plus 5. And we have y minus 1 is 0. So again, can write like dy is equals to 9x squared minus 4x plus 5 dx, yeah, from previous example. So it is, now if we integrate both sides of our equation, we have y, the integral of dy is just y, and here integral of this function. Let's write directly the answer here. So it will be 9x cubed over 3 minus 4x squared over 2 and plus 5x, yes, plus constant. So it is, when we simplify, we get 3x cubed minus 2x squared plus 5x plus c. And now let's plug this initial value, and we have here, so 0 is equal to 3 times minus 1 cubed minus 2 times minus 1 squared and plus 5 times minus 1 plus c. And solve this equation with respect to c, constant, yeah, and this constant equals to, c equals to, let me move it to the left side, all these numbers, it will be minus 3, so plus 3, plus 2, and plus 5, and it is 10. So C equal to 10. And when we write our answer, here we have y is equal to 3x cubed. Solution of our differential equation will be minus 2x squared plus 5x plus 10. This is solution. Okay, now let's consider the next example now. Example number 3. Solve the initial value problem. Okay, what we have d, so y derivative is cosine t plus sine t plus sine t, and we have y pi, it's 1. Okay, so the first step, again, finding this y, and then defining constant. Second step it is. So dy, again, yeah, dy it's cosine t plus sine t dt, and we integrate both sides of our equation, we'll get y, it will be sine t minus cosine t plus constant. So now 1, it's equals to just putting pi, yeah, just putting pi. So here, look here, it's t, it doesn't matter. So t, or it depends on dt now. So we can write this y derivative as dy over dt, not xt. So here sine t, sine pi minus cosine pi. It's 1, yeah, plus constant c. Okay, so now 1 sine p it is 0 and cosine p is minus 1. With this minus it will be plus 1 plus c. They are cancelled and hence c is 0. So the general solution is sine t, solution of this cosine t plus 0. Just it. And let's consider the next example. So what we have here? Here we have y second order. Yeah, this is second order differential equation, but here we have initial value problem, and it's not so difficult. It's very close. So 2 minus 6x, and now we have two conditions. When y prime in 0 it is 4, and then the next one is y 0 it is 1. So this is also initial value problem or Cauchy problem. So here we need to use these previous statements twice. So and we get solution here. However, we have second order differential equation. So it is like d square y over dx is 2 minus 6x. Yeah. And now, firstly, we need to find what? We need to find the first order derivative. To find first order derivative. So it will be now dy over dy over dx dx. So d square dx square here also. If we integrate it, 2 minus 6x, yeah, we should move this multiply this dx square here, and we have d square y integral. It will be 2 minus 6x dx square, yeah. So and now here we can find firstly this one, the first order derivative. So we have first order, so it will be just y prime equal to this integral 2 minus 6x dx, yeah. It's visible here also. The first order derivative, when we first time integrate, we have this one. Here integral of second order derivative will give us first order derivative, and this integral will give us 2x minus 3x squared plus c. Okay, now we need to put this initial value, this one, yeah. And then what we get here, so 4, it's equals to 2 times 0 minus 3 times 0 plus c. It is squared, it doesn't matter. So hence c is 4. So hence c is 4. Okay, now we can write our y prime as 2x minus 3x squared plus 4. So this is first one. And now, let me continue here. So, after second time integration, here we get, now it is first order differential equation. And now we need to integrate one more time it, so it will be now y equals to integral 2x minus 3x squared plus 4 dx. So now it gives to us the next expression. So it will be x squared minus x cubed and plus 4x. Plus 4x. Now, plus c. Yes, the next constant, for example, c1 now. Sorry. c1. Okay, it's now. Now we use the second condition. y0 is 1. So 1 equals to 0 minus 0 plus 0 plus c1. So it means c1 is 1. So we get this c1. Now what we have? Now we have this two constants, yeah, and the y is now equals to x squared minus x cubed plus 4x plus 1. So this is the last solution. We found our y. And now we'll move to the next section, separable differential equations. So, a separable differential equations is any differential equation that we can write in the following form. For example, here we have function n y dy over dx equals to mx. Such kind of equations we call differential equations separable differential equations. So here, of course, these two functions, continuous functions, and how to integrate it. So we can multiply two sides of our equation by dx, and we'll get ny dy equals to mx dx. And then integrate with respect to x. Integrate with respect to x, and we'll get here answer. So now I want to show one example to clearly explain this type of differential equations. For example, so, for example, let me write the first example. dy over dx equals to y plus 2. So look here. After this one, we'll get here the primitive of n function, and here primitive of n plus constant just. So now let's solve this example using this case. Okay, so here our n of y, it is, look here, we can write it like dy over, if we divide by y plus 2. So we need to move all functions with respect to y with one side with dy, and all function with x to the other side with dx. Is it clear? So that's why we call it separable. And now here we have just dx, yeah, and then our n of y, it is 1 over y plus 2, and our m of x, it is 1. It is 1. Okay, now what should we do? Just integrate. If we integrate, we have integral. So this is integral of rational function, and we need to decompose it firstly, and after decomposing we'll get here. So 1 over y plus 2, it is 1 over 2, 1 over y minus y plus 2. So we'll get this function. And then what we have here, we have 1 over 2, 1 over y minus 1 over y plus 2 dy, integral of this function. It's equals to, here we'll get just x plus constant, because it's just dx we have. So now if we continue, it will be now the integral of 1 over 2 natural logarithm of y over, is it clear for you? So it is natural logarithm, here natural logarithm of y minus natural logarithm of y plus 2. And x plus c. So we'll add the c only one time, not 2 times. It's constant, any constant. Hence, we have 1 over 2 natural logarithm of y over y plus 2, and it's equals to x plus c, or it will be, if you multiply by 2, it will be a natural logarithm y over y plus 2 and it's equals to 2x plus any other coefficient, c1 for example. It's also constant, 2c, it is just c1, any other constant. This is the answer, and it is in implicit form. Or we can write it in explicit form also, with either power, yeah? Okay, this is solution. And now let's solve the next example. So, solve the differential equation. X squared plus 4 y prime, it's equals to 2xy. So this is also a separable equation, and here we need to write as x squared plus 4 dy over dx to xy. And now, I said we need to move all x to the one side, all y's to the other side. And what we'll get here, so x, and it will be dy over y. Look here, we divide by y. This is goes to down, and dx goes to up. It will be, and this x squared plus 4 also goes to down here, and it will be 2x over x squared plus 4 dx. We get this expression, and after integrating, what we have, it will be natural logarithm of y equals 2. So now look here, we can this x write in differential, and it will be dx squared, 2x will be in differential, and x squared plus 4. So what we get here, it is, and of course we have here natural logarithm of y. It will be natural logarithm of x squared plus 4 plus constant. Okay, and now because we can write also like this, x squared plus 4 also we can put in the differential. Then so look here, if we have here natural logarithm on the right side, we can change our constant as x squared plus 4 as natural logarithm of any c1. It gives us just constant c. Why we need this c1? Because to write to simplify our solution, I mean, here we have just now natural, now we have two sum of two natural logarithms. It will be the product, yeah, so natural logarithm c1 times x squared plus 4, or x squared plus 4 we can write in brackets because it's always positive. And now we have this one, we have two natural logarithms, and we can, if we equate, it will be y equals to plus minus c1 times x squared plus 4. So this is solution of our equation. Its solution. But here we have plus minus, yeah? So we can write this, instead of this plus minus, we can do this sign in constant and write just generally c x squared plus 4. It's same. Let's consider the next example. Find solution of differential equation y, all solutions y prime minus x e to the power of y. So pay attention, in differential equations in previous example we found general solutions because we use here constant, yeah, we have family of solutions. If you use this plus c constant, we'll get the family of solutions. So it's called general solution. Okay, now let's try to find it. So it will be dy over dx, it is minus x e to the power of y. Now, hence we'll get dy over e to the power of y, and minus x dx. Let's integrate, and we'll get here integral of e to the power of minus y dy, and now it will be minus x squared over 2 plus c, the next one, yeah? And this one is also minus e to the power of minus y, and it's equals to minus x squared over 2 plus constant. Or we can write as e to the power of y is equals to x squared over 2 plus c, dividing by minus 1, yeah? So now minus y, of course. This minus y now equals to, we can write in logarithm, so natural logarithm x squared over 2 plus constant, or y is equal to minus natural logarithm x squared over 2 plus constant. So this is solution of our example. And now, next example. So, number 4. And let's find here particular solution of differential equation y plus 2 y prime natural logarithm of x plus 1, and the provided y1 is minus 1. So it looks like initial value problem. So this is initial value problem, and firstly we need to solve this equation and then find put these values and find a particular solution, not general solution, particular solution here. So this is separable variable as equation with separable variables, and it's x y plus 2 dy over dx equals to natural logarithm of x plus 1. So dx to the right side again, and the x to the right side again, and that's all. So we have y plus 2 dy equals to natural logarithm of x plus 1 over x dx. And let's integrate it. And after integration we have so this is the left side is y squared over 2 plus 2y, and the right side is, we need to integrate it. So we can write this integral as natural logarithm of x plus 1. This 1 over x in differential, it will be d natural logarithm of x. So, or we can continue it, and we can write, instead of d natural logarithm of x, as write d natural logarithm of x plus 1 also. So the answer here is natural logarithm of x plus 1 square over 2, because now it depends on our this natural logarithm of x plus 1 and plus constant, any constant. Okay, now we need to find this initial value, yeah, here. So firstly let's simplify it. So it will be y squared plus multiplied by 2 4y, and it's equals to natural logarithm x plus 1 square plus c. Okay, now put these values. Minus 1 squared because y is -1 squared plus 4 times -1. Instead of y, we need to put -1. Instead of x, we need to put 1. It's natural logarithm of x. It is 1 plus 1 squared plus c. We need to find this constant. In particular, we need to find the solution. So now it will be 1 minus 4, and it is just 0 plus 1, 1 plus c. Hence, c is what we'll get here. So it is -4. C is -4. So in particular solution of our differential equation, this is general solution, and now particular solution will be y squared plus 4y, natural logarithm of x plus 1 squared minus 4. This is particular solution. And now let's consider the next example. So it's number 5. Okay, so solve the differential equation prime cotangent squared x plus tangent y is 0. So we write this equation as follows: dy over dx cotangent square x and it's equals to minus tangent y. So hence we have cotangent square x dy equals to minus tangent y dx. So we need to divide now, and we'll get here dy over tangent y equals to minus dx over cotangent square x. It's dividing here. This one is to the right side. Okay, now but here one addition. So when we're dividing cotangent and tangent, we can miss the solution, and let's check possible missed solution when it's dividing. So how to check? Take derivative, the product tangent y times cotangent square x is 0, and hence tangent y is 0, and it means y is pi over 2 plus pi n. So and we have dy is, when dividing, dy is 0. So substituting this into initial equation, we see that y is p over 2 plus pi over 2 plus pi n. It is solution. And the second possible solution is cotangent square x is 0. Here we get the answer x is pi n. X is pi n, and dx is 0. So but dx is 0, it's not satisfied. So satisfied the initial differential equation. Now we can integrate. We can integrate these two ones, and what we have here, it will be dy over tangent y and dx over this one. So this is when, if we move to sine and cosine, it will be cosine y over sine y dy, yes, and it will be sine square, sine with minus of course, sine square x over cosine square x dx. Okay, cosine y to the differential and sine square x also to the differential, and or here we can use the reducing the power. So I think with reducing the power, or let's firstly solve this first one. It will be natural logarithm of sine y, yes, because it will be sine y, and the answer is natural logarithm of sine y. And now this one we can write as minus integral, so it will be 1 minus cosine square x, yeah, it is better I think, 1 minus cosine square x dx, and then let's continue. So minus integral it will be 1 over cosine square x and minus 1 dx. So 1 over cosine square x, it's just tangent x. It's equal to minus tangent x minus x and plus constant c. So the answer here is, the final answer is natural logarithm of sine y is equals to minus tangent x minus x plus c. And also we have the solution y pi over 2 plus pi n. Because it's satisfied, dy is 0, this one. When we take derivative, here we'll get 0. But in this case, it's not satisfied, our dx is 0. This is final solution, where n is n from the set of integer numbers. And now let's consider the next example, exercise number 6. So find the particular solution of equation 1 plus e to the power of x y derivative y prime e to the power of x. Okay, now it's satisfying the initial condition, y0 is 0. So initial value problem we have. We rewrite our equation as 1 plus e to the power of x dy over dx e to the power of x. Okay, so divide both sides by 1 plus e to the power of x, and we'll get dy. It's equals to e to the power of x over 1 plus e to the power of x dx. Yes. So since 1 plus e to the power of x, which is greater than 0, we didn't miss the solution here. So always we need to check it. We can miss the solution when we're dividing. And if we have solution here, we need to write this solution also. Okay, integrating this equation, we'll get the next one. So y is equals to integral of e to the power of x over 1 plus e to the power of x dx, or you can write this in the differential, so it will be d e to the power of x over, yes, 1 plus e to the power of x. So this is equals to, or we can write here also adding 1. So adding 1. And it will be natural logarithm of e to the power of x plus 1 plus constant. So the solution is natural logarithm of e to the power of x plus 1 plus c. This is general solution, but you need to find the initial. So determine the constant c is initial condition. We have y0 is 0. Let's put it, and we'll get 0. It is natural logarithm of e to the power of x, so e to the power of 0 plus 1 plus constant. So this is natural logarithm of 2. So hence we have c is minus natural logarithm of 2. And then we can write the initial solution. It will be e the particular solution, natural logarithm of e to the power of x plus 1 plus natural logarithm of 2. This is particular solution. So this is last example for today. So we began new section with you, differential equation, ordinary differential equations, and we started from initial value problem or Cauchy problem and differential equations with separable variables. I think it's clear, it's not so difficult topics. They are not so difficult topics. So if you have any questions, you can write on discussion group, and the next time we'll continue this section, the ordinary differential equations. Thank you for your attention.